Cold, wet, and raining seems to be haunting me lately. Our first customer up today is complaining of no heat. They mentioned that when they put it in air conditioning mode, they also had no air conditioning. The outdoor unit seems to be running in both modes. However, there's no air coming through the vents. So let's get over there and take a look at it for them and see what we can find. So we can hear either a transformer or a relay. Sounds like it's the motor. Not hot to the touch. So I tapped it with my finger. I don't know if you can see it start to spin. So that is a quick and easy way to determine whether or not it's a capacitor. Essentially, all these things are really doing is it's altering the electric sine wave that's, peaking and dropping every second, and it is slightly shifting it over. A capacitor is a phase shift device, so it's essentially letting one magnet be immediately energized, and the other magnet energizes slightly behind or before that one, so it starts the rotation. So if you can ever just barely tap one of these motors, indoor or outdoor, one direction or the other, doesn't really matter. It will start spinning that direction. So your capacitor gives it that spin and gives it the direction of spin, as well as lending it efficiency. There is no safety disconnect downstairs. A lot of these older homes can be grandfathered in where they just never had one. So we'll be speaking to the rental company about that. As for now, we'll kill it with the breakers, and your guess is as good as mine. I know that's the outdoor unit, but we have a bunch of, looks like a 50, which is probably the stove or range, and a bunch of 30s. So we're just going to kill everything that's 240 volt and confirm when we get downstairs that we have no power. Alrighty, we'll just confirm that we do not have any power. And we do not. So we'll go back over to our capacitor. This looks like a 5 microfarad. Just to confirm, we will double check. Getting no reading at all. So we'll check our new one. Look good. Once more, we just wire it back up. This one is easy enough. Just 2 terminals. Both wires come directly off the start side of the motor. Well, one of them is actually bridged over to the common inside the motor, but it has its own 2 wires for the motor. So easy enough. Just hook up the 2 wires. Either side does not matter. We should be good to go. If I can get my arms in here. All right, and now we go turn the power back on. All right. Have power, obviously, since the motor started. Pull our probes loose. And we'll switch over to amperage. Check our amperage draw. It's going to be higher because the door is open, so it's allowing it to free run wild, basically. We are still pulling 1.5 amps, which is within saying 2.63 for full load, so we're good. you're not allowed to make fun of my terrible in the truck artistry here. So, I know we dealt with a capacitor last, I think it was just the other day, but same idea. These are run start capacitors, and if you can imagine, your motor is like this. So you have your common wire coming in, you have a magnet essentially for your run winding and a magnet for your start winding, and your start winding is hooked to this capacitor. It hooks back up to the same line as your common. Your run winding goes through your fan relay and attaches to your other L2 wire. So if you can imagine, your power coming in is doing this 60 times a second. So it's up to 120, then down to negative 120. So that's giving you your 240 volts. It's changing 60 times a second. And what your capacitor is actually doing is, as that sine wave is charging up, it's building up in this capacitor on that one plate. And as it gets to the peak and starts slipping back down, all of a sudden those electrons that are trying to jump over to the other side can't anymore, and suddenly they pop back out. So you have a slightly shifted sine wave now, so that this magnet and that magnet are energizing at opposite times. So essentially it's what gives you our rotation, and while it's running it gives us efficiency as it's going, so it doesn't overamp, overheat, gets up to the correct speed. So pretty neat little concept, but again, capacitors are one of the more common things that go out throughout the summer and the winter. But both of these that I've recently done, looks like they're both blower capacitors, so it is something to look for. It's usually one of the first things we look for. Yeah, suddenly we're getting a complaint that the blower motor is no longer operating. But now we'll get on to the next one and see what we can get it to.